We are on page 106 of the exercise book, and I brought these over to my notebook. Number 17 says to consider the following graph. Brenda has to determine whether the graph represents a simple interest investment or a compound interest investment. Based on the appearance of the graph, Brenda decides that the function is linear. She then concludes that because simple interest is a linear relationship, the graph must represent a simple interest investment. Which of the following is true? And they gave us the formulas that we would need, and here are our choices. Brenda's answer and her reasoning are correct. Brenda is incorrect. Simple interest is a linear relationship, but the function is not linear. Brenda is incorrect because the function is linear, but simple interest is not a linear relationship. Brenda's answer is correct, but her reasoning is not. The graph represents a simple interest investment, but the function is not linear. Brenda is incorrect. The function is linear, but more information is needed to determine whether the graph represents a simple interest investment. So there are two questions of utmost importance. Number 1, is simple interest a linear expression? And let's first look at that. The simple interest formula is interest equals principal times rate times time. Okay, that is a linear expression. There are no exponents of second powers, and it does work in a linear fashion. You plug in the variables, you get an answer. It is linear. So yes, it is a linear expression. So let me look at my answers. I can eliminate C because C says it's not a linear relationship. So let's get that one out of there. Okay, that's really all we can eliminate right there. So let's look at the second question that I need to decide. Is the graph linear? I'm going to say, just looking at it, I don't think so. Because linear is a perfectly straight line. And this one almost has some sway to it. Right here, it almost looks like it's part of a parabola that is growing. It's not a perfectly straight line, according to what it looks like. But we need to know if it is a perfectly straight line. And I'm going to use the consecutive differences test to decide that. I'm going to make a table with 5 coordinate pairs. And we don't have to do the math. They've already given me the math. So the first one is 0.00. That's the y-intercept. Then we have 1 and 152. We have 2 and 308. We have 3 and 469. We have 4 and 635. And we could keep going, but this is enough to tell me what I need to know. So let's see what the first level consecutive differences looks like. So 152 minus 0 is 152. 308 minus 152 is 156. 469 minus 308 is 161. And then 635 minus 469 is 166. So this is not common, it's not linear. If it were linear, it would be common at level 1. So let's try it one more time just to see what happens. $156 minus 152 is 4. 161 minus 156 is 5. 166 minus 161 is 5. And I'm thinking I've maybe made, oh no, I haven't. That's where that sway comes in. This is not a parabola either, but there definitely is something weird right there. You see how that's not perfectly straight. It's almost a slope that's coming. It's just not linear right there. So this graph is not linear. The function is not linear, but the formula is. So this is linear. This is not linear. No, it is not linear, but yes, the formula is. So let's look at the answers. Brenda was correct because her reasoning was correct. No, her reasoning was not correct. Brenda is incorrect. Simple interest is a linear relationship, but the function is not linear. That is the answer I want. Brenda's answer is correct, but her reasoning is not. The graph represents a simple interest investment, but the function is not linear. If it represents simple interest, it would have to be linear. So that's not the one we want. Brenda is not correct. The function is linear. No, it isn't. If it were linear, it would check out at the first level. So all of those are incorrect except answer B. Okay, let me crop this one down and we'll take a look at number 18. We're almost done. Okay, for a given function, which statement is true? To find the first consecutive differences, it does not matter in what order you subtract consecutive y's. Well, if we've learned anything, we've learned that the order matters on this stuff. So you have to subtract them in order. If the first consecutive differences are not common, then the second consecutive differences must be common. That's not true either, because we've seen some that never came out to be true. If the first consecutive differences are positive, then the function is linear. Well, that positive has nothing to do with it. What we're looking for is whether or not they're common. So that statement, as it's written, is a false statement. If the first consecutive differences are not common, then the function is quadratic. May be or may not be. If it's quadratic, it'll work at the second level, but if it's not quadratic, it could go on forever. If the third consecutive differences are all equal 0, then the function is quadratic or linear. And that is true. That's where I told you that once you get commonality, every column after that will be zeros. So the answer to this one is E. That's another one of those theory questions. And then let me see if I can fit number 19 in here. I'm not sure until I read it what we'll have to do. We got to do common consecutive differences, but it is linear, so I think we can fit it in right here. I'm going to put the problem right up here and build my table down below it. Consider the following graph. What is the common consecutive difference? So let's set up one more table. And I'm not sure how many points I can get off there. I may not need it to be this big. But let's put our X's and Y's down. And we're going to have to look at the graph to do that. So let's pull some points off of this graph. I have 0, 0. That's a good one. Then I have over 1 up to 3. Over 2 up to 6. Let me get 6 points. That's a very good number to have. So we have 0, 0. We have 1, 3. 2, 6. 3, 9. 4, 12. And 5, 15. So let's bring those points down to our table. There's 0, 0, 1, 3, 2, 6, 3, 4, 3, 9, it looks like a 4, 9, 12, 4, 12, and 5, 15. Okay, first thing we want to check is whether or not they are consecutive. The X's are consecutive, and they're all different. Okay, so here come the consecutive differences at the first level. And this looks linear, so I think we're going to be okay right here. 3 minus 0 is 3. 6 minus 3 is 3. 9 minus 6 is 3. 12 minus 9 is 3. 15 minus 12 is 3. So I like E for my answer here. By the way, your slope is also 3 because you're rising 3 and running 1 on each of those. So it is common at the first level, and that difference is 3. So we don't need all of this. That one worked out okay. And that brings us to the end of this lesson. We have done all the review problems, all the textbook problems, so we are done. I will see you back in the next lesson. We'll be looking at lesson 6.3. And very soon we will be finished with this whole chapter. It's been a long time coming. I will see you soon. Bye-bye.